Well, welcome everybody to Module 2, Class 1. I'm glad we thank so many people who have been on this module. So first of all, thank you very much for coming. I'm Tom Breza, I'm one of the hosts. For the two, my colleagues Oliver and Tristan, obviously, just for those people who don't know. Our meetup is completely volunteer run. It's basically we're doing this as ourselves. It's not sponsored by anyone. So obviously, in order to make this project sustainable, we are looking of ways how this can happen. How this can happen. And one of the ways is basically finding a sponsor. But as well, there are things which you, if you're willing, can do. Yes, how you can sponsor us. Number one. We prepare a couple of memory sticks which you can potentially use. It's a fully bootable operating system Linux, like a live USB. If you can't set up, let's say, an environment where you can use C-Lion on it, it can be helpful to you. You can purchase that. That will support us. We paid for the memory stick something like £7. Recommended price £15, so a couple of pounds will go basically towards the uni. But as well, if you know anybody, any company who would be interested, let's say, do maybe banner on our website or some kind of way of doing something with us, we're open to this kind of suggestions because basically we want to ensure this project is sustainable.
But what do you mean by doing something with you?
For example, putting, as I said, putting a banner on our website, maybe putting a banner next to the class, maybe getting access to some of the people here who are as the recruiters, or goodness know. Yes, we are open to suggestions. Yes, some people might just do this for a good press. Let's say that they've been recently. Let's say some press actually give them some beating because they were very naughty. In general, like if some big company, for example, and they want to show actually we're quite good. That's not true. We sponsor good people. Yeah, so stuff like that. I didn't name anyone, so I think I'm okay on that.
So we're not looking for sponsorship from anyone like Halliburton or something.
Guys,
I said like Halliburton. I didn't say Halliburton themselves. Obviously, Halliburton are a completely legitimate company.
Blue people.
Yeah, great. That's.
I have an idea that you can explore.
Send this to me, yes, because let's not waste time for this. Because
hold on.
The class is.
This is now. Oh dear. Hold on.
I can. I'll scroll in this time.
Okay. Hello and welcome to C++ London Uni. I'm not really doing the intro. We're sort of doing a pre-intro bit with a recap of the questions from last time. So, hands up who actually did the test last time round. Who's here? Okay, so there's more people that did it than are here. That's cool. Okay, it must have had a lot of online people. So these are the stats for the questions essentially. So we've obviously got one. What is true? Is it statically typed dynamically? Duck typed or stereotyped? Those are obviously silly answers. The majority of you got that right, as you can see. A few of you thought it was dynamically typed. It's not. It is, of course, statically typed.
What's duck typed?
Duck typed. If it's the saying, if it looks like a duck, waddles like a duck, and quacks like a duck, it must be a duck. So duck typing is a concept you can use in C++, but it's also one of the pitfalls. So it's when you think you try to use something as if it were a duck, but it's not really a duck. So, which keyword is used for a function of no return value? Everybody got that right. That was excellent. I threw in void t there just to see if anyone would go for it, but none of you were sent off the path. That was excellent. Then the next was to select all statements that are not valid C++. And as you can see, there was nobody was misled by this. They realised this was valid. A few of you thought that const auto I would be invalid. It's not.
Person.
Perfectly valid. Yeah, one person. But the interesting thing was that quite a lot of you were caught out by auto const I. More of you thought this was invalid than thought that const I equals 5 was invalid. But unfortunately, the majority of you at least got one correct on mutable int I is 5.
Parents for initialization.
Yes, I suspect the parentheses might have been a bit of a throw off. And then for this one, obviously there's many ways you can write it. So interestingly, the only one that two people actually wrote the same way was an answer that was in fact incorrect, which was const float 4.2.
From each other.
You were required to you were required to name the variable, so that probably explains why. But you can see we got a few ones that were not quite right. Like some people declared a double when I said declare a float. Some people, instead of putting 4.2, would put 4.5 or just 5. That's not the number I asked for, I'm afraid.
Close enough.
But yeah, I suppose close enough. I would give you, if you were consistently wrong like this, and you get half marks for at least knowing the language syntax, even if you couldn't read the question properly.
What does F do again?
It declares it as a float. So if you did say 5.0, it would be a double that was 5. But this is again not the correct value, so I wanted 4.2. But you can say 5, but it's meant to be 4.2.
You've done const auto I.
Oh, 5F isn't valid? Oh, I might have to rescore that. Ooh. Yeah, I was slightly harsher on this test because I did say in the beginning that you were allowed to go and run and test your own code before you put it into the form. So bugs were marked down because you could have run it through a compiler first before you entered it.
But it would take even more time to do.
Would potentially take more time, yeah. So instead of string, what is stood? It is a namespace, of course. Nobody got that wrong. That's excellent. And then, of course, we asked, please select all the options that are true. And quite a lot of you actually got this one wrong. So they said that a function can't be called until it's been defined, which obviously contradicts it can't be called until it's been declared. Some of you actually answered that you chose both of them for some reason. Obviously, they are contradictory terms.
We had a discussion.
We had a discussion about this on Thursday, yeah. But if you notice the way these questions are designed, they're all sets of contradicting statements. So, of course, it can't be called until it's been declared. You don't need to define it yet. But obviously, even though quite a lot of you got it wrong, over 58% still answered it right. So some of you just went, I'll just choose both. The majority of you, fortunately, got the question correct about where it's generally recommended to place a function definition in the source code. And, of course, the vast majority of you got it correct that you use #include to include header files, and of course not to include CPP files. And then again, there was a small number of you who just checked both. If you selected a contradicting statement, then I negated the score. Okay, so all statements guaranteed to satisfy the if condition. These were slightly tricky. This one obviously was the simplest. X is true if X, of course. If X equals 0, this was a slight catch out. This is doing an assignment. Yeah, this is doing an assignment. I was wondering if to be nastier and doing X equals 0 if X equals 0, just to make it even more cruel. But I didn't go with it in the end. No one selected this one correctly. Obviously, X is false. This inverts the statement, so not false is true. So this executes. Absolutely right. Some of you were caught out by this one. The numeric 5x does not equality compared to true because 5 isn't actually a Boolean true. More specifically, true gets turned into a number and it gets turned into 1. 5 doesn't equal 1, so obviously that statement doesn't pass.
We could convert.
But yes, because in this case, true gets converted to a number, so true becomes the number 1. In this particular case, 5 gets converted into a Boolean, and the rules then say that, well, from a number to a Boolean, as long as it's not 0, it's true. So this obviously does run, and you got that right. And then a couple of you were caught out by this one, so we just declared X, and then we did if not X, and this is completely undefined behaviour. You have no idea what is in X. You have no idea whether this will execute or not. So we cannot say that it is guaranteed to satisfy its condition because the statement itself is undefined behaviour. Then we said select the option about the above code, which it's not showing me for some reason. We basically sort of had A followed by B followed by C, and you correctly said that, or sorry, A was an argument, B was assigned from A, and C was assigned from B in an inner scope. So obviously this was the correct answer. A couple of you thought that inner curly braces, an inner scope in a function was not valid, and it is. But nobody got the ordering wrong, so that was another fairly easy one. And then I asked what's wrong with the code. And a lot of you obviously noticed that there was no return statement for the function, even though the function said it returned an int. So quite a lot of you got that right. It doesn't return anything. All these are obviously no or none, of course, not quite. But yes, that was another nice one. And then I asked for people to write a for loop. So various correct ones. Not sure what was going on there. You just missed out the L value name, the letter I from the plus plus, sadly. But obviously most of the marks there for that one. And there's obviously several ways people did it that were valid. I wasn't actually requiring the curly braces. Someone even went as far as doing an int main, although they did manage to miss the ending curly brace, and they double declared I for some reason. And this was actually undefined behaviour because they redeclared it and shadowed it. But yeah, so a bunch of fairly interesting options there, solutions there. And then write a function taking a constant in reference and a double reference. This obviously was designed to sort of make you think and take it step by step. And there's a variety of answers, so I'm just going to pick on whichever one is first and correct. I think this one basically does it. So you returned a double ref, which is what I asked. Returns an empty double. I didn't say what to call it, so you can call it anything you like. It takes a constant reference, yes it does. And then a double reference, yes it does. It squares the int values, well I times I, yeah that's perfectly reasonable. Adds 0.5, yeah it does. I didn't specify whether that was a double or a float, so that's perfectly fine. You assign it, they assign it, excellent, yeah. And then of course just return it. And since it's a reference, it's going to return a reference 2D. So this is a perfectly valid implementation. This one sadly not. This is actually an XOR, exclusive OR operation. It's not going to do to the power of like you would think in most calculators and math. So that somebody was caught out by that. And there's a few other ones obviously. Someone had a go but didn't quite get there.
Someone did a face, did a smiley.
Yeah, someone had a go but didn't quite get there. And yeah, so the average scores were quite good, but I can't now scroll up, so I'm just going to do it on my Mac and tell you. Where is it? Forms.google.com. So if I just give you a breakdown of the averages, it comes up to me. So the point distribution was most of you got at least half on the bell curve. One of you got 19 points. Who here got 19 points? That was the highest score. They're not here? Okay. Okay, well, since you're not here, I would ask if you wanted your name said out loud, but since you're not here, I'm not going to do it. And yeah, so overall, the vast majority of you got somewhere around half or more. A few people struggled, but the median was 15. The median was 15 out of 21 points. So there was obviously a grand total of 21 was the max score. And that's it for me. So that was our little intro. I'm now going to let Tom do the full intro for the actual session.
Cool, thank you very much.
Take it away.
So, where were we? Okay, so if you would like to help us and give us a bit of help, as I said, the best way, if you know anybody who would like to, like a commercial, a bigger company would like to sponsor us in one way or another, send them our way. Alternatively, we are trying to raise some money for a replacement MacBook. Tristan MacBook unfortunately decided to die because Tristan is using his laptop mostly to write the slides for the class and obviously run the class. It's a good idea to help him with that nice thing. So we managed to gather close to £400, over £400 now. The goal is 1750. So we're getting there. If that gives you benefit, you're very welcome to do. Otherwise, don't. We're not trying to, get the money out of our students. The goal for us is to make the classes always free.
It's not. It's not working now.
Yeah. We'll check what's happening. because what I did, I tried to switch from my bank account to Tristan. So because I don't want money to go to my account and then I need to transfer money to Tristan. So basically, we were updating. Maybe something didn't go as according as it should be. So we'll check that. Now, once the class today is finished, we're going to pub. You're very welcome to join us. Buy these guys a couple of beers, some food. So as a way of saying thank you for them, if you wish, and talk more about C++. Fun facts, something which you might find interesting. In last 28 days actually, people watched us for 5 days and 19 hours in total. So, and since the beginning, so pretty much the year we're doing the C++ London Uni, that was 34 days. So somebody was sitting for 34 days and watching us talking. And the 90% of the people are from UK. So we are helping, all British. Now, just a reminder for those who don't know, our classes are weekly on Tuesdays, always on Tuesday. And majority of the time we're in the Skills Matters. So if you want to join them, you have to RSVP on their website. Thursdays or classes in in Mimecast, you have to RSVP on our website if you want to get inside, because we have to print badges for these places. On Thursday, we have workshops where you train what you learned today on Tuesday with some experienced developers. So we need you to RSVP so we can tell some experienced developer that somebody actually is coming from the students, so they will not waste time. If you want the latest updates, please do follow me on Twitter. My Twitter handle is xxvms, but we're trying to work out something to somebody to overtake the proper uni Twitter handle, and maybe that person would be more qualified than I am for something like that. I have batches of licenses. A couple of people send me requests, so I'll be just sitting and making that. But if you need license, email me, and I will send you license. My email address is tom@pcservicegroup.co.uk. And pretty much that's all from me, so thank you very much. Don't forget about these guys when you go to pub.
Well, at long last, welcome guys. Thank you for your patience. Apologies, even though it wasn't my fault, it was the train company, but Anyway, yes, hello, here we are. This is the first session on Module 2. Which, it being the second module, I've come up with the snappy title of Module 2, or at least a working title, because, well, I haven't thought of anything better yet, but maybe by next week I'll have called it something different. So yes, well done to everybody who took the test last week, and yeah, pretty good scores, so pretty chuffed with that. Everyone's seems to know what they're doing, so that's awesome. So well done, ladies and gents. Normal feedback slide, but in case there's anybody who hasn't seen it before, we do like you to join our little Slack group so you can talk to us and we can talk to you. Those are the instructions that you've all seen dozens of times by now, or at least 6 times before. I mentioned this last week, but for the people who weren't here last week, Ollie has been busy on his 6 days a week he's not here, and he's been putting together this series of videos about test-driven development in C++. He's got 3 of them so far. Each of them are about 2 hours long, so there's a lot of material there. And they're a little more advanced than what we've covered in the class so far, but if you're interested, those are the links. They'll be in the slides that I will remember to put up this week because I forgot, so apologies. I'm sorry, my bad. But yes, or you can just search C++ London Uni on YouTube and you'll be able to find them. Okay, so last week we talked about const references how they're a bit different from, or references to const things, I should probably say. How they have this special magic property of being able to bind to R values. We mentioned that briefly. I rapidly had to sort of rumble through namespaces, and I will make time for a little more thorough going over of namespaces, because I know a lot of people came away quite mystified last week, I think. So we'll find some time to delve into namespaces in a bit more depth. And we also, as you've just seen, we had our end of module quiz, and this was going to be the part where Ollie came along and did his thing, but he's already done it. So anyway, this week, it's module 2. We're going to start doing the fun stuff now. And we're going to start off by learning about defining our own types. Why we do that, how we do that. We're going to look at structures, data structures, structs. We're going to look at structs, and we're going to look at member functions. So that's what's on the menu for today. And yeah, I think we'll have time to get through things. Does that sound promising? Yeah, I know you've been sat there for a long time, patiently waiting, with only like pizza and beer to tie you over. So I don't know how you've managed, but yeah, thank you. Anyway, let's go back. Let's go back right to session 1 of module 1, and talk about types. So now I know you all know this stuff because we sort of asked it on the quiz, but what is a type? What do we mean by a type in a programming language sense, or specifically a C++ sense? I've heard something said, but weird echo. Okay, so what's a type? What do we mean by a type? When I say something has type int or type float, what does that mean?
Defines type of value that a variable can take, or a piece of code or memory can take.
So a type defines the type of something?
Yeah.
Yeah. Okay. Yeah, well, we're getting somewhere.
Characteristic.
A characteristic, oh, I like that one. Yeah? So here's the thing, when we have an int, that's just 4 bytes of memory, right? It's 32 ones and zeros. And a float is 32 ones and zeros. But they're different types. And the fact that they're different types means that affects the way we interpret that pattern of ones and zeros. So my definition, a type is a way of giving meaning to some data. By data I mean ones and zeros. And the type of some data tells us what it is, its characteristic, I like that word, and what we can do with it. Right? So what functions we can pass it to, how they can change those variables. Right. So, for example, we can multiply 2 numbers, we can't meaningfully multiply 2 strings. This is from 6 weeks ago, so, you know, either maybe it's a bit rusty, or maybe you're just like, yeah, I know this stuff, get on with it. So, C++ has all these built-in types. I don't know how many, about 30 of them, aren't there? There are loads. The ones we mostly use int, float, double, bool. Void is sort of a type, but it's not really, it's sort of special. There's char and char32, and there are lots of them. But these are kind of the main ones. And then we've used these standard library classes as well, string and vector. But again, there are quite a few different ones, quite a few different containers. There's a map, which is an associative array, or dictionary as they call it in other languages. We've got a standard list, which is a linked list, and standard dec, which is a queue, and yes. So C++ gives us lots of tools to define our own types, and these are the tools that are used to define these things like standard string and standard vector. Right? There's nothing magical about either string or vector. In principle, we could write those ourselves. Right? That's why they're part of the standard library and not built into the language, is because the idea of C++ is that it gives you enough low-level tools that you can build these high-level things on top. So it doesn't need a string class, a built-in string type rather, because we can make a string class. So to repeat myself, we can think about custom data structures. So rather than just dealing in the ints and floats that we've dealt with so far, we're going to think about how we can define data structures in order to organize the data in our programs. And this is really, really important. Obviously, we want to think about the functions in our program. What the functions do, how we organize those, what we call them. That's all important. But just as important are the data structures that we use, the custom types that we define. And I think that's really important, but people who know a lot more than me think it's important as well. There's a quote, I won't read it all out. But the difference between a good programmer, a bad programmer, and a good one is whether he considers code or his data structures more important. Bad programmers worry about the code, good programmers worry about data structures and their relationships. And I think this guy knows a little bit about programming. He's promised to be nice, so maybe he wouldn't say about bad programmers now. He'd probably say about experienced programmers and less experienced programmers these days. But, you know, he does know a thing or two about writing successful software projects, so I think we should listen to him. So I've said this, but to say it again, C++ gives us lots of ways to define our own data structures. We have structs and classes, we have enumerations, we have arrays, we have unions. Probably don't want to use the last two so much. But structs and classes are by far the most commonly used. We'll talk about enumerations as well. But today we're going to focus on structs. It's a very squeaky piece of floor I keep treading on over here, so sorry. Anyway. So what is a struct? Perhaps someone who's done a bit of C. Perhaps, can anybody tell me what a struct is in C or in a similar language that has something called a struct in it? Sorry? A group of variables. Yes, I love that. Yes, a group of variables. Very good. So, in C at least, a struct is a group of variables that become one unit that you can manipulate in one go. And in C++ we go a little bit further, because we can add member functions that we'll talk about later today that go with our data members or member variables. So a struct, short for structure, a data structure, it's a collection of data items, member variables we call them, data members, together with member functions that operate, that manipulate those data members. And perhaps a bit more simple than you would expect. We define a new struct using the struct keyword. Now, something that came up last time I did this, we were in this building in fact, I'm not sure if any of you guys were here. But I mentioned classes as well, and people got very, very excited about classes. They were like, yeah, that's the stuff, right, teach us about that. I don't want to know about any of this struct nonsense, tell me the good stuff. And the thing is, the words class and struct mean almost exactly the same thing in C++. Anything you can do with a class, you can do with a struct and vice versa. So people associate the keyword class with object-oriented programming, with inheritance, with virtual functions and polymorphism, all that stuff. But you can do all that stuff with structs as well. Structs there are two tiny differences between them, but those differences mean that structs are a bit easier to approach first of all. So today we're going to talk about structs, but I might slip and talk about classes or structs because they're the same thing. They're interchangeable, more or less, in C++. So if I talk about classes, I mean structs, and if I talk about structs, I mostly mean classes as well. So let's go on and define a struct. What does it look like? Well, I just said we use a struct keyword to introduce a new type, a new structure, a new struct into our program. And inside the struct, we list its data members. And the syntax for doing that is the same as you would do for a local variable in a function. So here I've declared a struct called point, and point has two data members, two member variables, fields as they call them in some languages. I have one called x, which is of type int, one called y, which is of type int, and I've given these initial values of 0, both of them initial values of 0. So to define a new struct, you say struct, you say the name, and then in between the curly braces, you list its data members using the same syntax that you would for declaring a variable in a class. And then importantly, because people always forget this, because I always forget this, because everybody forgets this, in C++ you need to put this semicolon at the end for sort of arcane syntax reasons. You don't have to do it in Java or C# or Swift or anything, but in C++ you do, so the compiler will usually bark at you if you don't do it, but sometimes you get funny, strange errors. So yes, commit that one to memory, because I'm sure Ollie's very nasty and will put it on the end of module test. So this seems simple enough. This is actually, as C++ syntax goes, this is not too bad, I think. So whenever we declare a new struct with a new name, it declares and creates a new type that is distinct from any other type. And you think, yeah, well, yeah, obviously. Why is that important? Because it means that if we give two structs different names, they're different types, even if their list of members are identical. So here I've declared two structs called first and second. And you see their members are the same. They're the same type, they're the same name, they even have the same initializer. But first and second are different types. If you write a function that operates on an instance of first, you cannot pass that function an instance of second. Right? They're different types. This is part of it's a very important part of the type safety guarantees that C++ gives you. Right? But it's quite, what are you about to say? Very important part of the type safety guarantees that C++ gives you. Right? So actually, if you could imagine a kind of function that would operate on anything that looked like this, regardless of what it's called, that would be duck typing we were talking about earlier. Anyway, what were you going to say, Ollie?
Well, I can just reinterpret cast first to second, and it just works. I've tried it.
That might happen to work for you today, but it's not allowed and it's bad and don't do it. You will summon the devil.
Yes.
Yeah.
Just because it has the same layout doesn't mean you can do stuff to treat it as if it is the same thing.
These are, if I have an instance of first and an instance of second, they are different things and I can't mix them. So again, there are languages where this isn't. This seems obvious, right? If you're just approaching this for the first time, you go, well, yeah, why would anyone think they're the same? But there are languages in which those two could be used interchangeably. So, yes.
Sorry, but actually, which kind of type is? If during the exam you asked me which type is I. Do I say is a struct type or is int
Okay.
or struct int? I don't know.
Okay. So this keyword struct introduces a new type, right? So it's a new type, like an int or a float or a bool, right? And this type has inside it a member called I, and this member has type int. Right? So whenever we create an instance of this structure, so we say first f equals whatever, we can say f.I to access the int that is inside that struct. I'll mention that a bit more in just a second. So the member I inside first has type int. Yeah.
If one of the members is int, can another member be like a string or something? Or
Absolutely. Absolutely. Very good question, yes. Yeah, if you have one member of type int, so it just so happens that I've used ints, but the very next bullet point, so you've anticipated very well. C++ places basically no restrictions on the types of our member variables, right? Technically they have to be complete types, but if you don't know what that means, then don't worry. So the language places no restrictions, but if you define variables, member variables of reference type, you're going to get strange things happen. So this is sort of a pre-warning. Don't use variables of reference. Don't use members of reference type. And there are a couple of good alternatives, better alternatives that you should use instead. So again, don't worry about this too much. But if you're going away and playing with these things at home later, having a member variable that's a reference does pretty strange things. And so don't do that. In short.
That doesn't mean that they get.
Sorry?
So if I was to create something else and assign it to a struct, they get a copy of that thing that I created.
Structs have value semantics by default, right? So just as we've talked about value semantics several times, if I have an int and I create another int, there's a copy, and then I modify the original, doesn't affect the copy, right? Value semantics that I've talked about several times. By default, unless you do special things, structs have value semantics as well. Structs and classes both have value semantics, right? And if you have a reference member, it sort of messes with that a bit and does unexpected things.
Maybe what they meant is that it's better not to have the reference inside the struct.
Yes.
But you can have another variable that refer by reference to
a struct.
Yeah.
You can have a reference to a struct. Of course you can. Yes, absolutely. Sorry, I misunderstood. Was that your question?
Yeah.
Yeah.
It does raise issues of ownership, though. If the struct has a member by value, then you're saying it owns this thing. Whereas when it comes to using interfaces, we're not into yet, but references aren't necessarily bad.
No. References in the language. References are a good thing. Having a struct member that it has a reference type is what I'm telling you to avoid. Perhaps I should just have skipped this because I'm sure nobody had thought of putting a reference inside a struct till I mentioned it, had I? No. All right, future reference. Just skip this till much later. Okay. All right, so we talked about how to define a struct. How to say to C++, here is a new type. But now we want to create an instance of that type. So just as we have types like int and float and bool, and we create instances of those types, we create instances of our user-defined types, of our structs. I'll show you the syntax for that in a second. In fact, I'll do it now. So to do that, we do it just as we would for an int. We just write the type, and then the member, then the name rather, and then we can initialize it in a pair of curly braces. So the struct point that I put on a couple of slides ago had two members. They were called x and y. There were two ints. So this initializes x and y with the values 3 and 7. And then we can access those members by writing the instance name and then a dot and then the member name. So P had members x and y. I'll write it back on here again. Should have put it back on this slide. So we've declared a struct called point, a new type called point, and it has members x and y, both type int. So here on this line, we're creating an instance of point, creating an instance of point called P, and we're initializing the members x and y to 3 and 7 respectively. Now, had I not put those values in, if I just put a curly brace, closing curly brace there, anyone guess what values the members would have had? 0 and 0, yes, absolutely. And if I'd just written 3, x would be 3 and y would be 0, absolutely. And so having created our instance, we can then access the members of it using this dot syntax. So we write the name of the instance, and then a dot, and then the name of the member.
Where did the 8 come from?
Where did the 8? That's just the value I've plucked out of the air. What I wanted to show you, what I was trying to demonstrate actually, is that we're allowed to change this member. This is not, we can access the member and it's mutable, we can change it. So after this line, p.x is now equal to 8 and p.y is equal to 7. Right, so when I first created it, x was equal to 3, y was equal to 7. I've then said x equal to 8. So struct p now contains the values 8 and 7. Does that make sense? Cool. And a really important part of sort of philosophy behind C++ is that user-defined types should be, as far as is possible, equivalent to built-in types. Or Jan Strauss, the inventor, he likes to claim there's nothing really special about the built-in types. That he wanted to provide enough facilities that you could write your own types that had as much functionality as the built-in types. So having declared our own type, we can use it anywhere that we would be able to use a fundamental type. So we can have it as a member variable of another struct. We can use it as a function parameter, as a function return value. We can use it as the element type of a vector, right? Anywhere that you can use a fundamental type, you can use your, I was going to slip and say class type, your struct, right? So that's user-defined types, or at least one kind of user-defined type, structs. A struct has members. The members can have any type they like. You can have a member, you can have one int and one string and one float, and in the real world, you can have, it's not necessarily a good idea, but you can have struct classes that have dozens, hundreds of members. There's not really any practical limit to it. It's not necessarily a good idea, but you can do it. Right, so these can have any type you like. They can have other struct. You could have a standard string as a member. Well, that's just another kind of user-defined type. Happens that the user that defined it in that case is the standard library, but
Can you have another user-defined type inside?
can you declare another struct inside a struct?
Like user-defined type.
Do you mean declare one or put one in?
Yeah, like for example, I'll create a struct, let's say cat.
Inside that struct.
Yes, so we will have a member. So I create
Oh,
some level.
you don't create it inside. You could. Yeah, the answer is yes. You can put user-defined types in user-defined types. You can also define your own user-defined type in your user-defined type. So you can have a struct in a struct. But that's I'm talking about the definition, not the actual. You can have a struct in a struct that lives inside. The definition lives inside the outer struct, and it can then have that as a member.
So is this what you're talking about? We declared a struct cat.
Yeah, exactly.
Which has, in this case, no members. That's a perfectly legal thing to do, by the way. You're not allowed to do it in C, but you are in C++, and it's actually a very useful thing to do for odd reasons. You might not think it's at all useful, but it turns out it is. But you can define your own type, a user-defined type, with no members at all. So this is perfectly legal, but I'm just using it as an example. And now I've declared this struct zoo. And the zoo has one lonely cat inside it, which I've called C. That's one thing you're not allowed to do. You have to give your members a name. You cannot make them anonymous.
You can make their type anonymous.
That's what the type is.
Have it in a struct and don't give the struct itself a name, so you have an anonymous.
Yes.
So you can do-
If you want to be evil.
Um,
So yes, if that's what you were saying, this is again a very common thing to do.
So what would be the value of cat in that case? Inside zoo.
Well, cat has no members, so cat.
No, but I mean, if you were to create a zoo instance
Yeah.
and access cat
Yeah.
without giving it.
You can't do anything with it. It's got no members. You can either think of it as having no values or having one value and every instance has the same value. Or you can think of it as having no value at all.
Okay, so if it wasn't a struct, there was an int there. So it's in the first example.
Oh, because I haven't given it an initializer, you mean? Oh, I see what you mean.
How would you have
Yes. So if you don't give it your own initializer there, you either have to write a special kind of function called a constructor that we'll talk about next week, or you must give it a value when you initialize it. When you create an instance, I should say. Yes. So you can leave these things off, but if you do that, then you have to give them a value when you create your instance. Otherwise, we're in that same situation of like when you just declare int I, you're not allowed to access it.
What's the use of having a struct without any members?
It's useful for what's called a tag type. So this is
overloads, right?
it's getting to pretty advanced stuff. But if you can have function overloading in C++. That is, we have functions that have the same name and are discriminated between they have different argument types. And if you want to control exactly which of those overloads is selected, you can use these empty structs for what are called tags. But that's, it's probably a couple of weeks away yet. Anyway, that's a bit of nattering from me. Time for you guys to get on with something, I reckon. So, just a little exercise. I don't think you guys are going to struggle with this. You all did very well in the test last week, so this should be a piece of cake, a walk in the park, taking candy from a baby, all those other things that mean easy.
Or if you had one structure coding, could you do that?
But if you do have any problems, then just yell and me or Ollie or Tom come along.
Yes. Create an instance of the same type. See, it's a dynamic.
No, but then when you say instances, what does that actually mean? then how do you referring to using A?
It's part of the statement, so that it's an anonymous struct. The struct has no name. It's, we're saying that these create A and B that are of this type. That's why that's what it's inside performance.
That's from A and B, that's type, then you can refer to the members using A and B.
Because they have no. A is separate from B. A is
There's
this
two different instances of the same type.
completely independent. It's A and B have nothing to do with each other.
So it's creating two separate instantiated variables.
Yes, A variables.
Of the type. Right. And then you can say A dot X because it infers that that is the type and that's the
No,
variable.
in those it's anonymous. Kind of knows.
Yes, it's like an auto.
Has an internal name.
It's
We
like
can't
an
use it.
auto.
It gives it an internal name.
Yes.
We can't
Does
use
it?
Yeah, it gets an
Although its
internal
internal name was A.
No, I mean the type. Type.
Yeah.
If I do that, that's now I can use that.
Yes.
That's the type. That's the name. If
Yes.
I do that, the compiler has an internal name.
So if you can give a name, can you still do this multiple instances?
Well, like this, if you have to do it here, I can't make. I have like.
Yeah, you can't do it
So
after
for example, so if I do that, this is useless. I have no way to create an instance.
Yes,
If I have one or more,
that's right.
then I can now use this double type.
What if you did call the type, so give the type a
Yeah,
name,
that's right.
then can you still do A and B?
Yeah, that's fine. It's legal as well. Just that kind. And then I don't need to use this crap. I just do this.
What does this do? Let's see.
Yeah, it's an instance of this. We'll see.
Right, okay.
So I'm going to see the rest.
Well, if I find the usefulness of doing it, then I'm sure it will be very wonderful, wouldn't it? Just thing is to understand when to use it rather than obvious you can do it if you know what I mean.
Struct. So it's only a class, so it's a class, right? And it's going to take a reference to the implementation. It's not going to own it. It's going to use it. It's going to need to use it when it's notified. You never put the interface as a reference number. So the reference to the interface has a number. Take it in the constructor, assign it.
Yeah.
And use it in there.
Reference numbers inhibit default assignment. You don't get your own time. So that's why.
I need to take it over. That's design because I'm saying I rely on
Yeah.
an interface. I can't default constructs. You have to do it.
I would prefer reference wrapper in that case because then you can get rule zero. Correct. Really should put that slide.
Reference wrapper must be assigned to. Reference wrapper can't be assigned.
No, so you still have to write the constructor, but you don't have to write copy, move, assign, assign. It's not-
Oh, sorry, no, that's not true. I don't have reference wrappers. I feel you can copy.
You can get a copy constructor, you don't get copy assign. Stick and block off.
I use on-block constructor. Doesn't matter. Public or private, does it?
Remember,
No, I can drop it. That's it's public. Just aggregate.
it's easier if I show you the solution. So when you do it, so that's. Student reference, so little and reference. Oh, it's a range-based. I'll put the solution on the screen.
We can copy the struct. Untitled, yeah, sorry.
So we need to.
Go ahead and read to the doctor. I want to use
Almost right.
Structs
So we need to take that
student
out.
type, you know, an instance of student.
Yeah,
You'll just say.
student.
You need an instance of the struct. All that struct says is I am creating you've stated that there is a type called student, and an instance of it shall have the first name as a servant.
It's a vector
You need to now
of
create an instance.
students.
So you have student X,
Right, student in between.
All right.
you create a
It's
variable
like
of
a
that type.
yeah.
That's just a type of function.
It has a different
Hmm.
test. Then I can say
So then we need to.
test dot first name.
Oh,
Right. So what we need to do.
So,
Yeah.
So a
So
student needs to have
you can also do it
the first name of the servant. So this is a student.
so which go?
where you declare
So write the word
test.
student in there if you want to.
First name, usually two strings. Inside the process.
Yes.
No, so if you just give that a capital comma,
First argument, second.
then that's fine.
Oh,
So
so,
that-
oh, okay, okay.
And then you need to do that.
So I thought I was arranging it.
No, because the student has both the first name and
I
the
need
surname.
to remove this.
No, so you change that to that, yeah. Just close that place. So print surname is a function, you need to give the function an argument. So that's what to pass. So let's just put that in the items. So what this is saying. So now, so that's it. Is this an item master thinking? You have to include string and include
Oh,
vector.
of course, yes. Because that's what I already got it because I thought
No, unfortunately not. So we need IO string. We also need string vector. Okay. Almost there.
we need something else.
So
First
what
bit is
type
okay.
does the
So I
vector
created my struct string,
So we're saying, when you say this, we're saying this is a vector
I'm
of
creating
students.
the
vector struct of type
A struct student, that's our new type of student. So when we go through the things that are in our vector,
Class using initializer.
it's going to students.
Oh,
Dropping equals. Yeah, dropping equals. Sorry.
This one. Oh.
No, you don't have to say struct student, you can just say student.
Should I put maybe the column?
No, you already got them.
What is it? I can't see what the type of block.
Okay, so this is
No, they
saying
are.
They are, but
go through our vector.
So we go great.
Oh, okay.
we're going to, for every student that's inside our vector of students, we're going to do this thing. What we're going to do is print surname. So we haven't actually defined our print surname function. So what we need to do is worry about that.
Now What?
So, when you did this, remember the difference between declarations?
Yeah.
So this line is saying there is a function called print surname that exists.
Yeah.
Well, we should get to
So what we're going to do now is we're going to define this function. Say there is a function called print surname. It does this.
Does it make it?
No, yeah.
Oh, yes.
No, so no, because what you would thinking of is if you added functions to structs in that header. So if you added some member functions to it,
It's we actually want to print. We want to print the surname.
Yes.
So this,
you'll use struct everything.
you don't have any. So
First name, last name, no, just
in this
Yeah,
in
you
this function,
put a function.
you've got a student called
Yeah.
X.
So for example, we take us.
And we want to access the name.
No, that's the definition.
What was the
Oh, to get rid of
to access the name?
just the yeah. So now it's perfect. So you've got declaration
And then it really helpfully tells you what the numbers are. So you say, so
Yeah.
down here,
It's very presidential.
Oh,
all the numbers handled in this
Right.
what's wrong? There's something. I have another question.
I have a quick question. If it's not compiling, we're saying student, it doesn't exist as a type.
Yeah, because obviously the compiler evaluates it from
Yeah, I get that. But it's I'm a student and I do it.
which came first, function or structure. That's it.
Right.
The compiler looks at the thing.
So it's structs have to be outside of me.
It's not be outside. Technically, that's legal. The problem is that your function came half before.
Yeah.
So it doesn't have students yet because you only declared it afterwards.
Should I declare this above it?
Oh, okay. Right.
So struct is literally outside the scope of the function.
So that's what structs
Generally, you want it to be as long.
So
Don't really.
which means struggling with what to put
Unless
inside.
you're making something really small in one very tiny case,
Like this.
like potentially like this, but you've got to pretend it's not. So you
Oh.
want it to be exactly.
There you go. If I hadn't even initialized the first member and I'd done a empty comma
So
surname,
in here,
you know what I mean?
inside this function,
It would have-
a student.
Would I, if I hadn't
So
provided
what we want to
which
do is
member I wanted to
access
print,
the
would it
member.
have printed just what's in there? So
You,
empty space.
no, you can't empty space. You could do curly braces, empty curly braces, but you can't just put nothing.
Yes.
No, so the member is already initialized as empty. So
Yeah, I know, but I get it. When you're calling the constructor, you mean from intent, it's like test.
Yes.
So then you can't just put a space.
And then it's first name
There's got to be something. So if you want the default constructor, because what you're really doing is you're saying, give me the default
So
constructor.
this says,
You have
okay,
to put what you've effectively
give me
done
the student.
there. Empty curly brace,
I want to access the thing called surname inside the student.
can't. Because otherwise it's just saying, well, why is there a comma here? A comma's not done.
So this,
So when you're explicitly providing arguments, if you want to just go to the second argument, you want to give something first.
yeah, and then we can't leave it empty.
so
So like
You can achieve the same goal, which is that you want to
So-
the default constructor of a string.
so I can't have done this.
Pretty sure that one. So
It's just expected manipulations for
precisely you need some expression. So if you want to achieve the same effect, just put empty curly
so
braces.
just as we were, so if we were to
That's it, called default
this,
curly braces.
say int,
Those must have been square brackets.
so this creates
That's just
instance.
called the default constructor of a string.
that's that C plus plus what you call the
So we can do exactly the same thing, but instead of declaring int, we declare a new type student.
So okay, I remember when you mentioned to initializing a value to a variable. If you don't find anything in the parentheses, then the compiler or whatever gives it some sort of default value. So for a string or a char, what would that be?
These
Garbage.
No, garbage is
Stu has type student.
just string is in
And I'm initializing two members of the student.
Strict, technically speaking, it's a user defined type. It just happens to be that the user
So this minus
the user is the user. But
first name
it's still considered a user defined type. Is a user defined type. Student string has its own default constructor. So if you provide nothing, if you get rid of the braces, you do exactly the same thing. Because when you have a user defined type, well, sorry, it gets so complicated. If it's a user defined type, so say you have a struct, and the struct has nothing in it but ints, and those ints aren't publicly accessible. Yeah. So you can make them private. Then you can end up with the same problem. You didn't explicitly set the numbers, then you know the fields, those numbers to something, so they are undefined behavior. With a class like a string, which has its own private fields, and it has its own default constructor, that has to be locked. You can't just construct a string and just have it valid in a valid state. Guarantees that it has to be in a valid state. You can construct something in it. You can't write, you shouldn't try to read from it. You can quite legitimately, ask for its size, and it'll say size is 0. Right, so it sets up some readable.
I'm not sure that you're any more in the line
construct
of
int,
No, I am.
and the int field will say.
the idea is that we can create
But you provide the
when we define our type, and then we can create variables that have that. So that's what we're doing.
Sure, the int says 0.
But I don't know what it's public and private. I'm assuming public means
Variables
like
students.
right here I could declare or use
So like
that
create
number
variables.
like I did here. So that means it's available to be public.
Now
Yes.
create
As a
a
function.
Private means
of our own
that
type.
it's
Only
itself.
internally is available to
So when your default
I'd say, probably
If anyone got a question, just raise your hand so
I
we
just,
can.
can I print this my class point element? That is the better word. Was it wrong with the element?
almost.
So it's your own types, you don't take
Okay,
the
so
educated braces. When you start
within-
out, this
so
is horribly nuanced.
this
thing.
range-based form says that
Many bugs
Yeah.
for many people.
we're going to go through my class,
Yeah.
and
Like this is
it's
how
going to give you back a
every
student.
single way to visualize
Student
it.
is valid.
Because it's so horribly confusing.
And then we want to
Oh, without
access
student.
If you
Oh.
want to construct instance at the end,
access. So
what
we
do you
use the docs. We need to
Oh.
access surname.
So in this instance, when I
Okay.
said
Okay.
use the default fund,
That's just because it's syntax
Yeah,
in a
we
file.
should print the surname.
Yeah.
In those cases, you get rid of it. But that's because you happen to know that std string is safe to do that.
but if I had some other
If you have
types,
int, if you have an int, it's very if you don't assign your int to anything, it just has
so if I assign int with the curly braces, which I usually do,
if you don't put anything inside the curly braces, it will be 0. But you know it exists.
I'm not sure if it's.
so okay. The reason it worked here is purely because of that defined behavior you mentioned.
Yeah, the std string itself has its own default constructor. So essentially, std string defines its own contract.
So
You can, when you make a start,
students, so this is a new type.
write your own user string, define your own user. As long as you're doing
Okay, we'll get to that. So we've changed the type against students. Now you have no type.
They
So
construct an
So first
instance
time,
declare another type.
time
yeah,
to see that So we make it when you're writing
So vector is it's called a
students of student names. So using the program, because I had a program. So the public records. First, the level for all the fields, for all the vectors, that is for all the vectors.
right?
And then the element
String
inside the vector, which
is
is my
like a
class.
vector except it's an array of characters. Right? So it always holds characters in it. It's got a lot of extra special functions.
Let's just make extension.
Honestly.
Create a standard vector of students.
That's just creating
A collection of something.
For the
and then I printed
this type.
as
Oh,
So
first name
for
brackets I
every element,
brackets 1.
what's the classes?
Well,
Every
let's
element
get the element of the array.
classes.
Let's just work our way through it.
There's many
So first of all, if you want to use vector,
Make your own student.
right. We only well, hang on. It's not big. We're commenting that.
Okay, for every class
C plus plus is type says case sensitive.
which is the name of vector, to print
Why is it?
classmate
Because you haven't
here,
included just
and
elementary
because I was writing my class dot classmate. Actually, it's classmate dot
ones on the top of the column is added for you.
one is the print vector, type is initial, this is the name of it, and two at a time. If you don't do two at a time, I suppose in my case I didn't initialize. If you initialize with some budget, like unknown.
Now we're saying now we've declared a new type. Define this function for print surnames, we take
I'm saying on fact.
Because for example, I'm very terrible with surnames, no? And I initialize this
no,
one
so this was
by name.
what we were talking about last week.
On
No, that's fine. I'll go through it.
That's very unknown, and then
You are so we've got
It's more efficient.
okay, now when you print, you should
defining
print it.
S as
student. S just teaches students, so we want to access S.
You should print them.
So.
Perfect.
Unknown,
Yeah.
unknown, right?
So I should have done that for you.
Yeah, it usually does.
Because where it doesn't find.
Yeah. Keep doing that.
Yeah, it's the just add into it. So, well, you actually
If we don't initialize, I suppose we will have problem. That's fine. I suppose we will have problem.
Oh
Because
no, it's wrong. I'm not sure if you get it.
So why are we giving that error here? Here's one thing to
Yay, totally good.
oh,
Function, so functions will
it didn't print anything. It just
Was
left
it?
blank without initializing. Okay, maybe it's a blank string. This one, well, that's the from the first exercise. Yeah. That one, that is blank.
Everybody
There
okay?
is this one. Then it's banana. Yeah, because the name that's okay.
Here we better
for
be done
the
right.
first, and the second we didn't declare. So I was supposed to put that given as an okay. That's
So now we declare
the one classmate was
Yes.
So they don't need to, well, we'll worry about that for a second. First of all, we want this to compile to roll.
Yeah, the Struct remains
Oh.
like it first started.
I have another question.
So now let's create a students. Yes.
Of license. Oh, essentially, yeah, of course.
Oh, this one.
Names.
Close.
Oh, looking up.
So this is saying I'm creating a variable for this.
Yeah,
So
then
No.
initialize
So you
this.
type,
This.
right close. So,
Zero.
curly braces, right?
Yeah.
Initialize a particular type.
Give it the argument
So you're going to need a pair of curly braces for the vector itself.
Yeah, and then you need them some.
And then you need the ones to be initialized. I think you we got a comma at the end of it.
Thinking.
Get away with just
Zero
nothing.
is the first element.
Hang on, okay, so if you want to break nothing in here. No, just do keep the curly braces but have nothing inside. So the inner one, get rid of two quotes and the comma.
No, but the first element of
Because
one
these are default constructs. Yeah. I mean, it would have worked. There's nothing wrong with what you had. It was also valid. Oh,
No,
yeah.
it's
It's the same as what you had, the two empty strings.
I didn't want to do another student
Fundamental.
yeah, that's why it's still kind of
Oh, sorry, so we don't.
I don't know. I was just thinking when times
I
fixing
think
the
they
name.
show the solution. I can ask Ollie. Ollie, can you ask me something?
Yeah, sure.
This is all done, it's just an extra. If I want to, I created my class as a vector with my classmates.
Yeah.
And so blah blah.
That have last names or something.
Doesn't matter, I have we were trying with the float, we were trying all of this. We put unknown and everything.
Yeah, yeah.
Now the
You're
problem
getting
is,
a little bit ahead.
if I want to just change this one,
Yeah.
this my class 0.
So you need to close off the zero.
Ah,
It's a zero closed dot.
Okay, so everyone had a good
Dot front. Dot front is your vectors.
everyone had a good go at that, I think. Lots of good questions. So I'll go over to the solution. So first of all, we're going to print things, so we need to use our O string. We're going to use string, so we need to include string. We're using vector, so we're going to include vector. Pretty standard. Hopefully everyone is used to this sort of C++ horribleness by now. So first of all, we would declare our struct student. Let's create a new type, student. Now this, I think everybody got right, so this is excellent. So we created a student that has two members, both of type standard string, called first name and surname. And if you want to, you can give these what are called default initializers, so you can do equals whatever. You can just have empty braces. You don't actually need to do that with strings, but yes, it's probably good practice to do it, so I will in fact put it in.
So you have enough experience.
Yeah.
When it's just put curly braces.
Yeah, exactly. So. Okay, so we declared our type student. And now I've said I want a function called print surname, which returns nothing. Yes, come on, got to test you on the old stuff as well. Just we're on module 2 now. Doesn't mean you can forget all the module 1 stuff. All right, so this thing here is a reference to a const student. Now this was a bit confusing for the people who weren't here last week, I think. So 2 weeks ago we talked about references and how we can have this opt-in pass by reference thing in C++, so you don't have to copy. Function arguments. So where you can pass something to pass a variable to a function by reference. So if we didn't have the little ampersand here, if we didn't have the and, we'd be passing by value, and it would mean we'd copy our student instance into the function. Well, we don't really want to do that because these strings could be very large. They probably have to do allocations. We don't want to copy it unnecessarily. So we pass by reference. We pass a reference to a student. Now we're not going to, this is just going to print. It doesn't need to modify the student in any way. So it's good practice to make it const. So I said this last week for those who are here, passing things by const reference, as we call it. So putting const on one end and the ampersand on the other. That's by far the most common way to pass arguments to functions in C++. So this is saying, so the purpose of this example was twofold, right? First of all, it was to show you that you can use your types just as you have used strings and ints and all those things. You can write functions that operate on your own types. This is kind of the point of them, after all. It's no good having a data structure if you can't do anything with it, right? So we can define a function that operates on our custom type, and we can also form references to our custom types, and we can make them const, right? So exactly all the things that you've seen with strings and with ints, you can do them with a student or whatever other type you declare. Right, so we've got this function print surname, takes as its argument a reference to a const student. We've called it S. So let's have a look at the definition of this function. Standard cout and new line that you've seen dozens of times now. This bit in the middle, we're saying, okay, we've got a variable, a reference to a const student named S, and I want to access, so this is member access, this dot. I want to access the field, the variable named surname that is inside S. Okay, so does that make sense to people? Because this was something that I saw, people were trying to do student.s or student.surname or something. We have an instance, we have an object of type student, and we want to access the surname field of that object. Incidentally, before I go on, what would happen if I switch these round? If I put print surname up there and student down there? It'd get a bit upset. How do you mean it would get a bit upset? Exactly that. So exactly as we said with functions, you have to declare them before you use them. It's the same with any types. You have to declare the type or define the type up here before you can use it as a function parameter. Otherwise, because the compiler reads your file from top to bottom, if it saw that one first, it would get there and it would say, well, I don't know what a student is. I don't know how to interpret this name you're giving me. Right? So in order we have to write the things in this order. We have to define what a student is before we can use it. And then we get to main. Again, you've all written lots of main functions by now. So now, I've declared a variable called Tom.
Thank you.
This variable has type what? Variable, well, I'm going to get really technical about it. This variable has type const student, because C++ is strange and const variables have technically different types from usable ones, but I'm declaring a student called Tom, and I'm saying I'm not going to change it after I've initialized it. That's what this const means. Right? Because I presume Tom's not going to change his name anytime soon.
Georgina.
Well, not for the lifetime of this program anyway. So I've initialized, so again, this is the intention of this is to show you that you can have const versions of your own user-defined types, just as we had const ints, just as we had const float. You can have a const student. So we've got a const student called Tom, and now I've initialized the two fields of this struct, two member variables. I've initialized them to Tom and Reza, first name and surname. So again, most people, I think, this bit was okay. Right, this bit wasn't too confusing. The const, no, I don't think anybody made it const, but this just as an example to show you that you can. And then we're going to call our print surname function. Well, print surname expects as an argument a reference to a const student. I'm going to pass it Tom, which is our const student variable, and it's going to print. What's it going to print? It's going to print Brezza. Absolutely. Yeah. So we pass a reference to our variable. It's going to access the surname member of that student, and it's going to print it out. Now, I think a couple of people went on and did the second parts. So well done if you did. This is, again, a demonstration that you can use your own type wherever you can use a built-in type. So this is saying I want a vector of students. Remember, with a vector, we put the element type, the thing it contains, in these angle brackets. So this is saying I want a vector of student. And I've named the variable students. Now I've done the initialization on a few lines just to make it clear. So I've created this vector. It's got 3 names, or 3 students in it rather. Again, repeat Tom Brezza, Ollie Din, me.
If you want to include my email in there as well.
Ollie's mobile number is. So what you'll notice is that just as the way we initialize this, we didn't have to write the word student in there. But actually we can if we want to.
So was that constructing or replace that?
It's the initializer list constructor. Got to skip through all these lines again now. Get down there somewhere. So we can say this. This is saying I want a new student, initialized for these things. However, it happens that vector knows that it contains students, so if you just pass it thing in curly braces, it does the right thing. But you could do either of those and it would be okay. Or you can mix them like that. That's all those are perfectly fine.
Sorry, what's the last one doing? You just give them the
It's exactly the same. I'm just being more explicit.
But it already knows that the vector type is student.
Exactly.
So why
So-
would it accept student again, or why would you want student again?
You don't have to. What I'm saying is, it's not an error to put it there if you want to. Right.
But there is a mistake.
Sorry, just if we change the argument on a quick surname, we change it as student, so we delete const.
Yeah.
Does it give me problem there?
If I just remove this word const,
Yeah. And on the main scope, it's still like that. You leave it like that. So I got a student, a const student type, and the argument on the quick surname is just student.
good question. So maybe someone who was here last week can give you an answer. If this just said student, if we just deleted those 5 letters there,
Yeah, for
Yeah,
me it doesn't give
what-
problem because
would it
it's a
work?
variable, no?
would it work?
It will,
Yes,
but it can modify.
but it will modify the original variable.
What was the original variable?
The original is Tom Brezza.
Okay.
So whatever you change.
And what in particular have I said about this variable, Tom?
is constant.
Okay. So I can't change it.
No.
So if I tried to pass it to a theoretical change surname function that just took a non-const reference, I would get a compile error. So you're absolutely spot on. It wouldn't work. If this just said student reference and I tried to pass a const thing to it, it would say no, you can't.
So it would be an error or just warning?
No, an error. If you can't do it.
I don't understand why, because it takes any kind of variable, no matter if it's constant or variable number. Or
You can okay.
so it should.
So this is saying this is a read-only variable, right? And this is saying this is a read-only reference. And so that's fine. You can pass a read-only variable to a read-only reference. Okay? If you took the const away, this is saying this is a read and a write reference. So if I had a read-write variable, I can pass it to a read-write reference. That's okay. If I have a read-write variable, I can pass it to a read-only reference, because that's okay. I can read from a read-write thing, right? But if I have a read-only variable, I can't pass it to a reference
That can read and
that
write.
can read and write.
It's more like a sanity check, yes?
Oh, what, sorry?
Sanity check. So if I'm using this, let's say the print surname function,
It's-
let's say miles down there, and I don't remember that actually the Tom is const, so that's compiler basically will help
yeah,
us not
yeah,
to
yeah,
make
yeah.
a mistake.
Yes, it's
Makes sense?
very.
Okay, so here you see the old code, so pretty much everything is obvious. But imagine the print surname is miles away from the const student, so you don't see them on the same screen. So you see there's a function, and you say, oh, I will send it there. But you might want in that function write something to Tom, but Tom is const. So to prevent you from doing a mistake, the compiler will say, hold on, I'm not letting you to do that because this is a read-only variable, and you're trying potentially to have read and write. Read is fine, write not. And they just stop you, because if they would allow you to, potentially could be a big problem to find later. Was it?
Pretty much, yeah.
Thank you.
Okay, just to finish this off then. I said, can you print these things using a range for loop? So let's do that. So again, range for loops, we did this a couple of weeks ago. I'll throw a little wrinkle in here with auto and const reference, because I like to pile things on to just keep you on your toes. Okay, so remember with a range-based for loop, first of all, we need some kind of range. Now, something that meets the range protocol. Now, a vector does, so that's all good. So we've got this vector called students, and we say, I want to access each thing inside the vector in turn. Right? Do something for each student inside my vector. And we need to tell it what type we're capturing, what the type of the thing inside there is. So I'm going to name it S, so I can access it through the name S, and I'm going to say, I'm going to deduce whatever, so auto means just deduce the type for me. And again, I'm not changing it, so make it const. And I don't want to copy it every time, so just give me a reference. So every time I go through the loop, it's going to create a variable called S, which is a reference, a const reference to the thing inside the student, to the thing inside the vector. Right? So this is a very common thing to do with these range for loops. Right, it's just kind of abbreviate the type, or to use auto to deduce the type, I should say. So, given that we're iterating over this vector of students, what is the type of S going to be inside this for loop? It's going to be a student. Almost. I was asking a bit of a sneaky question, I suppose. It's going to be a const reference to a student. But yes, you're very much along the right lines.
You didn't need to put a reference there, I suppose.
I didn't have to, but if I didn't, it would copy it out of the vector every time. And because we've got students, a couple of strings can allocate, copying can be expensive, so we want to avoid copying them if at all possible. We know we don't want to change it, so we're going to say const. So const autoref is the right type to use in this case. Right? And then, so this is S is a const reference to a student. Print surname expect a const reference to a student, so that's handy. So we can just pass S directly to this function, and it's going to print the surname for us. So I don't have an example of this running, but you can hopefully imagine that it's going to say Breza, Din and Brindle. So So any questions about this?
How come Tristan and Ollie are students? They should be teachers.
We're students of life.
All right.
You go to the school of hard knocks, mate.
Yeah. Alright. Any serious questions about this?
You have
I
none.
can't be to insert stuff into the vector, you could use place back. Then you definitely need a constructor.
Yes. Yeah. So mplace back only works. Mplace back will try and call constructor. We haven't got to constructors, that's next week. So without going on too much of a tangent, student is a special kind of struct called an aggregate at the moment. Until we give it a constructor, it's something called an aggregate. Mplace back doesn't work with aggregates. It needs to be a class with a constructor. But that's next week. That's next week. Yes.
What's the reason for declaring next to the member variables of the struct?
Just up here.
Yeah.
This is saying that I didn't have them on my first run through, but this is saying if I just create a student and don't initialize the first name and surname, just say like, I'm going to squeeze it in here, student Z, and just don't initialize it myself, don't give it a first name and surname. It's saying just create these two as empty strings. So it so happens that for standard string, it doesn't make any difference. We could have left them off, but it's just a good habit to get into, to always give every member variable, if appropriate, give it a default value. So in this case, the default value is an empty string. Okay, we started late. That exercise went on for a little bit, so we're not going to have time to get through all of this. But we'll give it a bit of a start, and we'll carry on next week. We want to talk about member functions. So right at the start, I said that in C++, class type structs, they have member data, a list of data types that are collected together. It's a collection of data. We have member variables, and we have member functions that operate on those variables. So we can declare functions that belong to particular types. It's a bit of a strange notion. It's something I've been keeping secret from you till now. But C++ has two types of functions. And the ones you've been using so far are what we call free functions, otherwise known as non-member functions. But that's only half the story. We have these free functions, but we also have, just as importantly, member functions, functions which are bound to a type, functions which belong, which operate on an instance of a type. However, this might not be a complete surprise, because you probably have used some of these already, particularly if you've been doing the homework exercises. When you call vector.size, for example, that's actually calling a member function of a vector, right? Or or vector.pushback, for example. So you've used member functions, and you haven't seemed too confused about using them. But I didn't really admit to you that they exist. But here I am confessing that I've been lying to you for 6 weeks. Well, not lying to you, just holding something back. We can declare functions that belong to types, member functions. Now, fundamental types don't have any member functions. Only our own data types can have them. So to declare a member function, we write it inside the struct, and we do it with the same syntax that we do for free functions, for non-member functions. Right, so this is saying there's a struct point, It has member variables, x and y, exactly the same as we had an hour or so ago. But now I'm saying, in addition to these, it has a member function called equal to, that returns a bool, and takes as one of its arguments a reference to a const point that I'm calling other. Now, what do you think a function called equal to would do that returns a bool? It checks whether two instances are the same point, right? So equal to takes two arguments. Member functions have a hidden, or you can think of them as having a hidden argument that is the struct on which you are operating, right? So when I call equal to, we've got one struct, which is the instance that I'm calling the member on. We call it this thing, right? And then the other argument I've called other. So we've got this and other. And in the next slide or the slide after, when we define equal to, you'll see we compare the things from this against the things from other to see whether they're equal. So member functions operate on an instance of a type, operate on an object. So let's flesh that out a little bit more fully. I've written things in the opposite order now. Doesn't really make a big difference. So now I've said I have a member called x, a member called y, they're both ints, both given both default values 0. And I've declared this member function equal to, what's my other? Don't worry about this const for a moment, we'll come to that in a we're not going to have time today, but we'll come to it. Now I'm saying, if my x, remember, equal to is operating on an instance of a point. So if my x is equal to the x that belongs to other, and my y, this y, is equal to the other's y, if both of those things are true, then the 2 points are the same, and we're going to return true from the function.
Could I say this dot x?
You can't say this dot x, you can say this arrow x.
You can, or you cannot.
You can't say this dot, you can say this and then an arrow, because this is technically a pointer.
Okay.
So you have to use the arrow syntax rather than dot.
It literally is a pointer.
Yeah, it's not technically how it is.
Doesn't understand.
You can do starless, you can do auto ref myself equals starless. And you have reference to yourself.
So does this make sense?
No.
Where did the other come from?
Okay, so other is parameters of this function, an argument to the function. So when we call this, we'd have to say p dot is equal, or p dot equal to, and then in brackets we pass it another point to compare whether the two are the same.
It's very important to have the const parameter and the const at the end, so you can do a comparison when both of the const.
Don't worry about the const at the end, that's
You could
me being pedantically correct. We don't need to worry about that too much today.
you could
So
even
which values will be passing to other?
whatever we are.
It could be a cell, it could be a number.
This one, if we write this one with the students before, it's like having two students compare x, means first name and second name of two students.
Yes.
Ah. So this other is another.
No, the other. Think of you can remove the other, but then that will be variable which you cannot name. So
Give me a couple of seconds and I'll
what
write
you
something
say,
and hopefully
like,
make this a bit
I
clearer.
will be passing something to that function. I don't know yet what, but I need to name it somehow so I can access that. So for example, I don't know whether you come, yes, Barbara, or maybe Ollie will come, or Tristan. So I have to name you somehow. So just a name there as word use word other. You could use something else.
I think it's more about the motivation. It's like, so, well, maybe I'm wrong. Are you asking what point about happiness?
This other word is
Yeah.
referring to something outside.
It's
It's
a
not
name.
referring to itself.
It's a
No,
name
it could just be X. I could put X or
or
Yes.
potential
Hello,
students.
whatever.
Students which I want to compare. Apple.
No, it's the name. It's
No,
the
but
name.
it's
It's just the name
Yeah,
of
it's
the
a
type.
it's a name.
Just
It
an
doesn't
alternate
have any
name.
meaning.
Other is an idiom that you use.
Cool.
That wasn't me.
That doesn't understand that we are too late.
Remove your hands.
Yeah, just hit the button.
It's exciting.
Somebody's
That might be a bit
looking
too
at some
bright.
video.
Projector, but
I thought I put it back on the same level it was.
Somebody is looking at us a video and decided we need more romantic settings.
might be the cleaners being funny, but no, it's completely arbitrary. But obviously the point of the function is it gives you a way to compare, or sorry, allow people to compare two instances of your type. So you're responsible for managing that, right? You decide whether one instance of your type is equal to another instance of your type. So you implement this inside your structure, so you control whether something matches the criteria for being the same or not. But then it gives anyone using your point
That's
struct
too dark,
a convenient way of seeing if they are equal. Yeah, that's fine.
We've only got 10 minutes left anyway, so.
11.
But what I'm saying is, whereas for the argument other, it's coming from outside the
Yes,
struct.
somebody
Well,
gives
let me just demonstrate magically to you. So here I'm creating a variable named p, which is of type point, and I'm initializing x to 1 and y to 2. Right. So this point has the value y2. And now I'm creating a second independent point called q, which I'm initializing to 4, 6. So we've got 2 points. Now, here's the magic. P has a member function called equal to. So this function called equal to operates on P. So inside of this function, we can just refer to our members of this thing, this object that we're operating on. We can just refer to them as x and y, that's their names, x and y. But we're saying, is it equal to this other point? This other point. So I've passed in as q. Inside the function, we've called it other.
So the other is replaced with the q.
Well, this is just
Yeah, but
normal function, right? So inside other, I'm saying is my x, is this x equal to the x that's inside other? So this is the member access, we're accessing this object.
so by extension the q.
Yes, in this call, yes.
So effectively, you've got a function within a structure.
That's exactly what you have, yes. A member function. Yes. It's a function that belongs to a type. And it operates on an instance of that type. It operates on that type's members. It doesn't have to, but usually does. So this is kind of a strange notion to come to initially. Sort of a new, declaring a structure as a new type, this kind of collection of things, collection of data, that's okay. But these member functions are a bit of a jump, right? That hang on, suddenly now we've got non-member functions and we've got member functions. That's well.
So can the member functions work on multiple different types? Like it could be on type of, say, P, the Q could have been int or whatever.
I could call Q dot equal to P, because Q is a point, so we can access the member named equal to inside Q. That's a member function, and we pass it an argument. So we could could have had exactly the same effect by saying if q equal to brackets p.
But could the argument that member function takes, if only taking a member.
Oh, of course,
the int.
the function argument type could be anything. Yeah, just as with a normal function. Yeah, it just so happens that I've used. I thought it was a convenient example, but maybe it was confusing. Perhaps I should have picked a different type. Yeah.
So there's nothing to stop me from having a suite of other functions within the structure.
Yes, you can have as many member functions as you like. And it sort of becomes a matter of design, whether it's better to have something as a free function or as that is to say a non-member function, or as a member function. And yes, these become matters of style and of design, and you can find many opinions and many blog posts. If you want to boil it down to something, would be prefer free functions when you can.
Ooh, controversial.
Well, all right. Me and Scott Myers say prefer free functions when you can.
I'm not sure I agree with that, but so you wanted to be const correct on the member function's accessibility. You call it you consciously call it equal to an operator equals, right? You consciously avoided operator equals, isn't it?
Well, I thought doing introducing member functions and operator overloading in one step.
Yeah.
I might do it in two jumps. It's almost as if I introduced this function in order to next week say, wouldn't it be better if we called it something else?
Nice. Okay.
Yeah, I think about these things.
Still make it correct.
Yeah. Anyway, let me just. I want to find a convenient place to stop. You see, I don't want to leave you hanging halfway in a slide.
So here's the dark theme from my Harvey instead.
Oh yeah. So you get to admire the latest macOS. Yeah, okay, well, I'll very quickly say this and then I'll go over it again next week because I have a feeling this will have some head scratches. So, first of all, first thing to say is member functions operate on an instance. They belong to an instance of a type. They operate on that instance within the function. We've just seen it. We could just say x and y, and they refer to our x and our y. That's what I mean when I say we can refer to them without qualification. So in Python, when you write member functions, you have to say self.x. This was for the Python programmers to say you don't have to do that in C++. The second bit is perhaps a little more confusing. We've already seen that we can have a const instance of our type. We saw that with student, right? We said, here I'm creating a student and I'm not going to change it after I've initialized it, right? From now on, you can only have read-only access to the student. Right, so whenever you see const, almost whenever you see const in C++, think read-only. That's what it means. So if we have a read-only object, we can say which functions operate, which functions we can call on that read-only object. We can say our equal to function only reads the object. It doesn't modify the object. Because if you think about it, if we're just comparing to see whether two things are in the same place, that's a read-only operation, right? It's not changing anything. So to do that, to say this is a read-only function, a read-only member function, a const member function, we write the word const at the end. Quick quiz, why don't we put it at the beginning? Why did they choose this syntax of putting it at the end?
It's the bullet.
Effectively return type.
If I wrote constable at the beginning, that would be the return type. Yeah, so they couldn't put constant at the beginning, so they had to tuck it at the end instead. So that's why we put it at the end. Right, so what this const at the end here says is that equal to is a read-only function. It does not modify the points, the members of point at all.
More relevantly, it means you're allowed to use it when you have a const instance.
Yeah. So if we had a const point p, then we'd be able to say p dot equal to.
So if P is not defined as a const, you won't be able to call the equal
No,
to.
this was exactly the question we had earlier. We can strengthen, if we have a read-write instance, we're perfectly fine to call read-only functions.
Oh, I thought they simply meant it would simply give you the guarantee they would not modify struct P.
This function promises not to modify anything inside P, right? So, but we can pass it something that's modifiable. You can pass something that is modifiable to something that promises not to modify. That's fine. What we can't do is the other way around. We can't have an object that we cannot modify and call a function that says, I might modify it, depending on how I feel, right? So C++ protects you from that second case. So this idea of what we call const correctness, perhaps a better way of thinking about it is in read-only enforcement. Really important in C++. And this is a way of protecting you from errors. Also has implications for optimization sometimes. But mostly it's about protecting you from making silly mistakes. So this is saying equal to is a read-only function. You can call it on a const instance, a read-only instance of P. You can say what you couldn't do was if we didn't have the const at the end and you tried to call it on a const point, then it would say it wouldn't work.
Can I ask you something?
Yeah.
This cost at the end is just a way of saying, oh.
It's a guarantee that this thing cannot modify the members. Because within the member function, so if you've written const at the end, then it's as if these member variables had the word const in front of them, right? It behaves exactly as if. So any attempt to change, if you attempt to modify a member inside a const function, it will say you cannot do that. These things are read-only. So this is a promise. This is not advice, it's absolute requirement. Anyway.
You can do that in any function, couldn't you? It doesn't have to be in a struct to have that syntax.
You can only put the const at the end of a member function. Because if you want to think about it another way, this const is referring to the member that you're, the object that you're operating on. Right, so free functions don't have an object they're operating on, they just have their parameters.
Which can be const.
So you can mark all those parameters const, absolutely. Individually, yeah. As we've marked this parameter const, for example.
Basically, think of it that because it's a member function, it has this invisible argument, which is itself this, right? Which that const at the end is referring to.
Yeah. Yes.
I mean, the const at the end of the member function,
Yeah.
we refer to the member variable. There has to be they're gonna be constant.
Inside that definition of that function, yes.
What stopped me to avoid to read the const at the function, at the end of the function, the two consts on x and epsilon.
Oh,
So I got.
that's a good question. That's a good question. We're slightly over time, so I'll answer it quickly. To say, what if I just wrote const there and there? What if I declared these two things as...
Yeah.
Right. You can do that, right? That's allowed. You can have a member variable that has a const type. But that means that even if we declared a point that wasn't const, we still couldn't change its members. Right, so I'm going to have to use another piece of paper. I know people want to go, so I'll just do this very quickly. I'll just do x. So sorry, I'm getting confused here. I'm trying to do things quickly. So I said we've got a struct point, and it's got a member that is const. A const member. Right, so now, because I was drawing it quickly, I haven't done the y. But so we've got struct point. It's got a member that is a const. So now I've initialized p.x to 3, but now I can never change p.x, right? You notice p itself isn't const, but its member x is const. So if I try and assign to it, if I try and change it, I'm going to get an error. Yeah, const member variables are weird.
Doing that first definition of point P equals 3, effectively trying to...
It locks the value of x in forever in this case, because we're saying this is read-only.
Whereas constructing
Yeah.
Oh,
is the first, is the creation.
Right, so I could create, let's get rid of that because that's an error. I could create a different,
the 0 is the default value. It's not.
0 is the default value, it's the one that would happen. Run out of letters. Alright, so I can have a point P and this initializes it to 3, this initializes it to 4. Here, I haven't given it an initializer. So it's just going to take the default value, which is 0.
And from that moment, you cannot change this.
Because of this const here. Yeah. Normally, you would not declare member variables as const. Anyway, apologies again for the slightly shortened session. You've had 5 minutes extra to compensate on the end. I will definitely put the slides up this week, and we'll carry on with member functions next week. And we'll do lots more fun stuff involving operator overloading and all of that. So thank you everybody for coming. That's it for this week, and I hope people will join us for a beverage. Thank you and good night.